Hello everyone, in this video I'll try to explain how to use matrix algebra to solve simultaneous equations for an electronics student. As an electronics student, for our subject, electrical circuit analysis, we'll often come across problems such as the one shown over here, where we are tasked to find I0. In this case, we can try to use mesh analysis and apply KVL so that we can find our I0. Over here, we have 3 imaginary current loops, all in clockwise direction, and from here, over here, we have 3 imaginary loops, all in clockwise direction, labeled I1, I2, and I3. From here, we can try to find our equations. For example, from here, we can try to find our equations. For example, in the first loop. First, we'll start over here, where we have 24 volts. As usual, we'll write it as negative 24. Over here. First, we can try to start from our first loop. So, we start from here, negative 24. So, we start negative 24. After that, we'll go through here. So, realize that there are 2 opposing currents. First, we'll start in the first loop. So, we go through the voltage source, which is negative 24. After that, we'll go through our first resistor. Realize that there are 2 opposing currents, I1 and I2. So, we'll write it as I1 negative I2. After that, we go through our second resistor, which is 12 ohms. And then, there are 2 opposing currents as well. In this case, I1 and I3. So, minus I1. So, I1 minus I3. That is our first equation. Then, for our second equation, we look at the second loop. Then, for the second equation, we look at our second loop. We start with the 10 ohm resistor, and as usual, there are 2 opposing currents. So, we write it as I2 minus I1. Following that, we'll reach our second 24 ohm resistor. In this case, there's only I2, so we write I2. After that, we'll go through our third resistor. In this case, it's a 4 ohm resistor with 2 opposing currents, I2 and I2, sorry. After that, moving on, we go to our second loop. In this case, we'll first go through our 10 ohm resistor. There are 2 opposing currents, I2 and I1. So we write it as I2 minus I1. After that, we'll reach our 24 ohm resistor. In this case, there's only I2. So we write it as I2. Going through to our third resistor, 4 ohm resistor. In which case, there's a I2 and I3. So we write it as I2 minus I3. Hence, we arrive at our second equation. For our third equation, we will start from our bottom left as well, going to our top ohm resistor with I3 and I1. So we write this like so. For our third equation, we can start with the third loop, going through the top ohm resistor with I3 and I1. We can write it as I3 minus I1. And then going through to our 4 ohm resistor, we have I3 and I2. So like just now, write I3 minus I2. Then we'll go through our voltage source. In this case, our voltage source is 4I0. So this is where we put the little star. Remember, in our over here at the node A, we can find that there's another equation. So we have an input current of I1, and then goes out I0 and I1. Goes out I0 and I2. So we can rearrange I0 as I1 minus I2. After that, we replace it over here, getting our third simultaneous equation. After simplifying all 3 equations, simultaneous equations, we can find that it is something like this. Then we can rearrange them into a matrix. Then we can after simplifying our simultaneous equations, we'll realize it as something like this. After that, we can rearrange them into a simultaneous equations. After that, we can rearrange them into a matrix. For example, we take all of this and then we can rearrange them over here. Put another matrix called I1, I2, and I3, and finally we get the results of 12, 0, and 0. From here on out, we'll have 4 different methods to solve these simultaneous equations: Gauss-Jordan, Gauss method, Gauss-Jordan, inverse matrix, and Cramer's rule.
Hello, my name is Tong Kyung, and I'm going to explain the Gauss-Jordan elimination method. In order to differentiate the Gauss elimination and also the Gauss-Jordan elimination, we need to know that the Gauss elimination only stop at REN, but Gauss-Jordan need to stop at RREN. And to solve the simultaneous equation here, we need to write it in matrix form, and here is the A side and the B side. And to know about the RREN, we need to get every row with the leading one. And here is the equation: -5 row 3 plus row 2. Then we can get the answer here. And next we get the R1 plus 11 R3. Then we need to focus on the back one, and we get that the answer here: 0, -16, 16, and 12. And to make it easier, we can divide by 16 for the row 3, and we get that 0, -1, 1, 3/4. And next is -5 up row 3 plus row 1, and here is to get the row 1 and get that the row 1 but the second column answer is 0, and the -11 and 33/4. Here's the answer. And next is row 2 plus 24 R3. It's because here is the -1, and in order to get the 0, we need to use 24. It's more easier. And the answer is 0, 0, 12, 18. And also, to make it easier, and the column with the leading one, we can use the row 3 to divide by 12, and we can get that the row 3 answer is 0, 0, 1, and 3/2 for the B side here. And next is 11 R3 plus R1 to get the R1, and here is the answer: 11, 0, 0, and 99/4 for the B side. And the row, another row, there is just remain. And next is 12 row 3 plus row 2. Then we can get the answer here, and 18 in the B side. And to make it easier, we can get the leading one for the row 1 just divide the row 1 by 11, and we can get the answer 1, 0, 0, and here is the leading one, and 9/4 is for the B side. And also for the third column, and for the third row, here is the leading one for the third row, and the B side answer is 3/2. And to get the second row of the second leading one of the second row is just divide the row 2 by 24, and you can get the leading one here. And the answer for the B side here is just the answer. Okay, that's all. Thank you.
Hello, my name is MOHAMAD bin SADIK, and I'll be explaining how to solve a simultaneous linear equation using Cramer's rule. So we have the 3 simultaneous equations here with the variables I1, I2, and I3, and in matrix form they look like this, where there are 3 matrices: matrix A, matrix I, and matrix B, and their relationship together is AI equals B in this case. So the formula to solve for these variables are, the formula to solve for these variables are I1 equals to the determinant of A1 over the determinant of A. The same goes for I2 and I3, where I2 is A2 over the determinant of A2 over the determinant of A, the same as I3. So before proceeding any further, let's try to find the determinant of A itself. So matrix A is what we have here. So let's do cofactor expansion along row 3 as it's the simplest. To find the determinant of matrix A, let's use cofactor expansion along row 3. So we have -1, -1, and 2. Not to forget the sign convention for each element as well. So first we have -1. So column 1 and row 1 will be covered, leaving us with matrix -5, -6, 19, and 2. And the same will be done for the other 2 elements as well. So by expanding this matrix AD minus BC, we get 10 plus 1, 1, 4. Repeat the same steps for the other 2 matrices as well. Then our final determinant will be equal to 1, 9, 2. So once we have found the determinant for matrix A itself, let's use the formula now. To find I1, let's find the determinant of A1 over the determinant of A. So what does the matrix A1 actually mean is, so to find matrix A1, we have to replace the first column with matrix B. So the column column 1 will be replaced with matrix B, which is 12, 0, 0. So repeat the same steps as what we did for determinant A to find the determinant for A1 as well. So cofactor expansion along column 1 is the easiest, as there are 2 zeros in the columns. So we have 12. So blocking out column 1 and row 1, we have 19, negative 2, negative 1 and 2. And as you can see here, we have negative 0 and 0 here. So these two expand equals to 0 as well. So we can focus on only the first matrix. So AD minus BC, 19 times 2 plus 2 times 12, we get 432 over 192, which is the determinant for A that we found earlier. So I1 will equals to 2.25 amperes. So the same step can be repeated for I2 and I3 as well. So for determinant of A2, we replace the second column of matrix A with matrix B. And then do cofactor expansion along column 2. We have negative 12 in this case, as according to the sign convention, column 2, row 1 starts with a negative. So keeping that in mind, we get the final answer of 144, where negative 5 times 2, negative 10, plus 2, 12, times negative 12, we get 144, over our determinant A, which is 192, we get I2 equals to 0.75 amperes. So repeat the same step for I3 as well. Replace column 3 with matrix B, and you get 288 over 192. So our I3 equals to 1.5 amperes. But for this question, we are hoping to find I0, which is equal to I3 and also equals to I1 minus I2. So just in order to check, we have 2.25 I1 minus 0.75 I2, which equals to 1.5 amperes, which is also equals to the answer of our I3. So that is the final answer of this question, and I0 is equals to 1.5 amperes. So that's all from me. Thank you.
Hi, my name is Imran, and I will explain how to solve linear equation using inverse matrix method. From the previous explanation, we already have these three equations by using mesh analysis. So first of all, we need to rewrite it in matrix form, which is AX is equal to B. So to find the matrix inverse, there is two ways to do that, by using ERO and adjoint method. So I will show how to use the adjoint methods, which have 4 more steps. The first one is by finding the determinant of A. Since the matrix A is 3 by 3 matrix, so we need to expand the first column and the second column to the right side of the matrix. So the first step is multiply these 3 numbers in the green highlighted and add it with these 2 more green highlighted numbers. And for the blue highlighted numbers, do the same thing, multiply, but we need to subtract it. So for the final answer of determinant is 193. For the second step, we need to find the matrix cofactor. The basic formula of cofactor is negative 1 to the power I plus j multiplied by minor of ij. So for the example, I will take the cofactor of row 1, column 1. Since row 1 and column 1, the power will become 2. And the minor, we can calculate by cross multiply it. Since this one is row 1 and column 1, we will cross the first row and the first column. And this one is the minor of the C11. To solve it, just cross multiply it and multiply with the negative 1 to the power of 2. The final answer will get 36. So for the rest of cofactor, we will do the same thing with the first one. And lastly, combine all the cofactor becoming one matrix. So for the third step is finding the adjoint matrix. The formula of adjoint matrix is transpose of the cofactor matrix, which the meaning of transpose is the first row will become the first column and the second row will become the second column, and follow the same thing for the next and the next. And the final step is the finding the inverse matrix. Inverse matrix can be found by using this formula, which is 1 over determinant of A and multiply by adjoint A. Since we already calculate the determinant of A, we just put it in the formula and adjoint A into the formula. Multiply all the number in the matrix, and the final answer will become like this. This is the inverse of matrix A. So back to our main focus, which is solving this linear equation, which we want to find the I1, I2 and I3. We use the basic formula of matrix, which is AX equal to B. So we want to remove this A from the left side, so we will multiply both sides with inverse A, and this one will become 1. So the final formula will become X equal to A minus B. So the final step of the calculation is multiplication of both matrix. This is inverse A and this is matrix B. So multiply by using matrix multiplication, and the final answer is this. We can see I1 is equal to 2.25 ampere, I2 equal to 0.75 and I3 equal to 1.5 ampere.